Hello and welcome to episode 8 of Getting Started with Houdini, and in this one we will tackle the topic of creating clouds, rendering clouds, and as a result we will have a cloudscape that will look something like this. Of course everything will be super procedural, and we will be looking at fun ways of converting geometry into clouds using some of the nodes that come with Houdini. So let's get started. As per usual, let's save our project first. Let's make sure that autosave is on and let's begin. So first things first, naturally we'll have to go with the geometry. Now a couple of things about volumes before we do anything else, so that you know. Let's start with for example, a box, right? So we can convert a box into a volume by just typing VDB from polygons, shift enter, and you'll immediately see that we have distance VDB, which is SDF in other words, and we can of course enable the FOC VDB, and of course we can visualize volume and increase the density scale so we can see it a little bit better. Now as you can see, currently our box looks kind of coarse because the resolution of the voxels that comprise the volume of this box is coarse as well. So currently voxel size is 0.1. If I increase this, you will see that it looks even worse. So if we middle mouse here, we'll see that now we have 9 by 9 by 9. So we have 700 voxels with a size of 0.1.5. So let's increase to like 0.05. You'll see that it becomes a little bit more defined. And if we do 0.02, it becomes, well, even more defined, of course. Now, the interesting part is that you will see that the amounts of voxels are 51 by 51 by 51. Well, basically because we have the size 111. On each axis, we have the voxel size of 0.02. So 1 divided by 0.02 equals 50. And of course, we have 50 by 50 by 50. Which in turn ends up being 132,000 voxels. As you might imagine, it will also take a lot of memory. So if we increase the resolution of the voxels from 0.2 to 0.001, we will increase the amount of voxels by 8. So we will now end up with around 1 million voxels. Let's see. I press enter. And indeed, we have 101 in X, Y, and Z, and we have about 1 million voxels. Of course, it looks even better. Now, that's kind of like the basics of it. And let's get our squab, right? So here's the squab, and let's convert that to VDBs. So again, VDB from polygons, shift enter, enable density, and enable the visualization so we see it better. Now, as you can see, again, it is very coarse, very ill-defined. So we'll have to make 0.03 at least to see it a little bit better. VDB stands for Volume Database, if I'm not mistaken, and it's a way of containing the information about volumetric data in a sparse way. The other way of converting to volumes will be to create an ISO offset. However, let's first increase the uniform divisions to 200 or something. As you can see, it's very, very well defined. Let's make it 100, so make it much faster. Now, the difference between them is that you will see that VDB from polygons actually says we have a VDB, right? The sparse volume. And this has just the volume. It's not VDB, it's just the volume. As you can see, it's a different color. So this is air quotes dense volume or just volume. So sparse volume, it takes less memory to represent our geometry, it's faster to calculate, it's faster to simulate. Basically, it's the better, newer version of way of working with volumes. So that's that. Now, we can of course convert from polygons, like convert VDB. We can convert from polygons to VDBs. To VDBs, and then we can convert from VDBs to polygons. Let's make the ISO value a little bit better. And of course, as you can see, it sort of is a way to remesh. And of course, if we decrease the volume, the voxel size, you will see that we have more geometry. And interestingly enough, all of the geometry will be quads. However, the quads resulting in this geometry will have pretty bad normals. However, if we do the adaptivity, you will see it's kind of polar reduces itself. So we will use this technique for modeling later, but for now, just keep in mind that you can do this and we can do different interesting things with it. So that was our squab. What do we do now? Let's start with a sphere and start actually building our scene. So first things first, you'll see this is the sphere, so nothing special about it, but we can do the clouds. As you can see, it will convert it to cloud and it will be looking like the ISO offset. However, in fact, it will be creating a VDB, as you can see. Previously, if I'm not mistaken, a couple of full versions back, like Houdini 18, maybe 17, it was creating just volume. Now it creates VDB, so it's rather faster. Anyway, we have this cloud, and of course, we can do the cloud noise. Now, just before I proceed with the cloud noise explanation, I want to say that the cloud noise is, in fact, as you can see, sort of an HDA that has been a pre-built high-level tool, as the side effects likes to call it. And we will, of course, take a look at how to create our own kind of cloud formations, how to do volume VOPs, how to control our volumes with noises. But for now, I don't want to get ahead of ourselves, don't want to be over your head. So let's just work with this cloud noise thing first. All right, so in my opinion, clouds do not look like that more often than not. So what we're gonna do is, I think we can compress it a little bit, kind of like this. Increase the scale quite a bit. And what else? Well, for now, I think we're good. Next up, convert to cloud noise. Right, so the cloud noise, we can increase the amplitude. As you will see, it will create more wisps around our initial geometry. So that's what we need. As you can see, it already kind of has interesting effect. So next up, we can work with octaves and of course the roughness. So octaves, the best way to think about the octaves is to think how many levels of fractals deep our noise has. And roughness is how much of a difference within those layers of the fractals is happening. So let's increase the uniform sampling distance to something like 150 so we can see it a little bit more detailed. Let's first, for example, decrease the octaves to, let's say, 2. As you can see, it has much less detail. And of course, if we decrease the roughness, it becomes really, really blobby. So if we make octaves 3, you will see that it increases the detail. However, the little details that we have still are looking a bit blobby because the roughness of the detail is low. On the other hand, if we start to increase the roughness, the difference within those blobs becomes more and more pronounced. So if, for example, we have roughness 0.5, for example, and we have 5 octaves, you'll see that indeed it's somewhat a nice balance between the levels of differences and the roughness or difference amplitude. You can, of course, play with those settings however you want, as much as you like. I think we will stop with roughness something like 0.2 because I would prefer it to be relatively wispy, maybe even 1.1 or something like this. And I will increase the amplitude so that the noise destroys our sphere and creates a much more kind of representative of a cloud than it was previously before, as it was a sphere. You'll see that it takes quite a bit more time. So let's start to tweak our sphere a little bit. Let's compress it even more. And let's Control-C, Control-V the sphere. And I think we will transform it and move it somewhere like this. It actually doesn't really matter how we move it, just to break up our initial shape. So we get both of those, feed it into the cloud. you'll see that we have this thing going on. And let's see what this gives us. All right, so as you can see, we have some sort of a result. To my liking, I think the noise is a little bit over detailed, but I think the roughness and octaves are dialed in pretty well. So what we're gonna do is actually increase the element scale. Let's say 2 by 2 by 2. Again, it will take a little bit of time to recalculate, and all right. And here's the result. I think this looks fine, I think. Let's increase the amplitude to something like 1.9. Increase the element size to 0.9. Okay. Okay, this looks pretty wispy. I think this looks okay. We can tweak it a little bit more if we want. If we don't, you know, this will look just fine. However, as a final thing, I think we'll have another sphere, and this one will be kind of like elongated sphere like this. A thin one, really, really small. Let's see what we have. Oh, I forgot to merge it. So let's do a transform. Oops. Let's do a transform. Rotate it a little bit. And yeah, I think this looks all right. Doesn't look too bad. And let's actually start to create our floor of the cloud, the part of the cloudscape that was in the preview, that was on the bottom. So how do we do that? Let's start with a grid. Let's disable the view for, let's see. Let's start with the grid. Let's pull extrude it. Nothing spectacular here. Let's just create something. Then we go again, we make a cloud and cloud noise. Of course, we will not see a lot of things because the uniform sampling diffs is a little bit too coarse. All right, so we have something already. I think we can increase the amplitude. What else? I think roughness, maybe increase the element size. Okay, this looks fine by now. Next up, what we're gonna do is we're gonna cheat a little bit. It will not look super great in our viewport, but it will be looking just fine when we are gonna render it. So we'll have another grid. However, this one will be, let's multiply the size to 10 and copy the points. In this case, we have the geometry, and do not forget to pack and instance. This will be instancing and packing, of course, our clouds. Now, as you can see, this looks kind of weird, so we have to transform. Oops. Transform, rotate, and it's looking fine. Now, there is a little bit of gap between those. So what we can do is maybe increase the rows. Okay, if it doesn't look very well, if it doesn't look very good, I think we can fix it after we are testing it with rendering. Actually, what I want to do is a little bit of a mountain. We will displace our geometry just slightly, so it kind of looks a little bit less regular. So as you can see, it's really interesting already, right? We just literally copied a super simple thing, and it's already making a cloudscape. And of course, finally, we can select both of these, hold down the Alt, left mouse button, oops, and we have the merge. And as you can see, if we transform this a little bit higher, here it is, our cloud. All right, this is looking good already. Let's save. Let's go back to our stage, start typing import all. Then we start typing dome lights because, well, we need something to light up. And of course, karma. And the karma will be XPU. However, before we do that, let's actually create a material, library, enter XPU Karma Preview, drag and drop, set it to Geo1 component, and here we go. Don't forget to move this before the Karma settings. Let's actually apply some dome lights. This will be Houdini Peak HDRI. The Chiara Noon will be doing just fine. And of course, let's try to render. So definitely something is going on. However, as you can see, it's very, very, very dense. We can increase the density, we can decrease the density, of course. And this is looking a little bit better already. However, what I want to do now is actually, let's disable the rendering for a second. All right. I will move my camera somewhere around here. And now I'm going to hold down Control and click the area light. So now I can move my area lights around, and this will be kind of like those God rays going from the left to right. So disable the lock so it doesn't rotate with our view. As you can see, here is our light and here is our cloud. Let's see what we got. Move it before the Karma. Enable Karma. Let's check it out. Of course, for now, in my opinion, the dome light is a little bit overpowering, so let's make it 0.15. Okay. And we virtually do not see our area lights already, so let's make the intensity much more pronounced. Something like this. Actually, let's make the intensity for now. Let's make it 1. However, let's actually increase the scale of this light. Something like this. As you can see, the bigger it gets, the more lighting power it has. Okay, so what I think is missing is the overall box of volume. Let's create another geometry and let's create the box that will be kind of containing everything that we see. So let's create a box. However, we will not make a box that will be, super huge, because the only thing we need is to create something to contain our fog volume. So in fact, we can do VDB from polygons, Shift Enter. Voxel size 0.1 should be fine. How many? We have 1,000,000 voxels. That's actually overkill, I think. Let's do it really bad quality, right? We don't need good quality. So what we can do now is transform. Increase it by, let's say, uniform scale, not even 10, but let's say 20. Let's disable this and see that our box indeed does contain everything that we need, right? And now I will enable back the conversion of polygons, and let's see what we got. Again, as you see, this is a little bit too dark, but we go back to our stage. This is getting re-imported. Let me go back to our Houdini GL. And of course, we go to our material library. We create another XPU Pyro preview. Drag and drop somewhere here, because we know that this is geometry 2. That's our box. Go back to our Karma. Let's press rendering. And I don't think we'll see anything. The reason being, because we have to tweak the density. And if we increase the density scale to somewhere around 0.1, kind of like this, we indeed will have pretty much everything back and looking fine. Right, so let's get back to our stage. No, before we get back to our stage, actually, let's tweak the absorption color of our hero cloud. Let's decrease the density a little bit so I can navigate a little bit easier. Navigating becomes a little bit wonky when you have the clouds, because you're never sure where actually your cursor is. So let's fix that. Let's create a hold down Control, left click. Let's create a camera. And now, when we move the camera around, we can control it a little bit better. First, let's go back to our material library and let's get to Karma Preview 1, and let's tweak the absorption color. So I want them to be ever so slightly getting kind of like sun color when they are absorbing it. Next up, we can tweak the scattering phase. However, in this case, the fact that our big light comes from the left to the right, I don't think we need it that much. For example, if we actually had the lights behind our cloud, whoops, I think I have to disable the view of our camera. If I had the lights behind our cloud like this, the scattering phase will be behaving a little bit more obvious. So if we make it somewhere like 1, it will be scattering in the direction of the light. So again, for our case, it doesn't really matter, because if we look through our camera, we'll see it comes from left to right. So we don't have lights that are going towards our cloud or from the back of our cloud. Then the scattering phase will be kind of more obviously contributing to the whole thing. Anyway, so let's get back to our stage. Control S, go back to our objects, and let's work on our clouds a little bit more. First of all, I don't think I like the wispiness of this thing that we have. I think, first of all, we have to increase the uniform divisions, even maybe 350, and then maybe destroy this thing a little bit more with increased amplitude of our noise. Okay, this definitely changes up things a little bit. Let's see how it works with our copy and instance. And this does not look too bad, I think. We'll see in the rendering. And of course, let's now try to work on our cloud. First things first, increase the resolution to something like 250 first to have a better preview. And then let's work on our cloud noise. I think we can increase the element size even a little bit more, so it kind of like has this big changes. However, this looks a little bit too much. Of course, if you don't like the result that's giving you, we can actually offset the noise of the clouds, so it kind of gives different results. So as you can see, the noise sort of swims through the cloud, and with each time we get different results. We can make it move through the x-axis, we can make it move through the y-axis. As you can see, if I do it kind of slow enough, you will see that indeed it does look like it's swimming from top to bottom. As you can see, it really does makes a difference affecting our cloud. And let's just tweak it to the point that we like kind of what we see. I think this place is a little bit too much, if I'm not mistaken. Let's see. Yep, it's our sphere number 2, this transform. Let's move it somewhere. Let's move it somewhere like here, and let's see what we got. So this doesn't look too bad, I think. The last thing maybe I want to do is increase the roughness ever so slightly to 0.14, maybe 0.17, something like this. And finally, increase the uniform sampling diffs to 350. This will actually take some time to compute, but yeah, it wasn't too bad. As you can see, this is our cloud. And of course, we merge it all back, and we see the result. It's looking pretty good. All right, enable back our box and go back to our stage. Let's see what we have. And this is looking really good. Surprisingly good, I would say, right? So let's increase the density of our initial kind of box a little bit more. And you know what I want? I think we will change the area lights color ever so slightly. So again, it's kind of like this soft sun color. Yes, this is much better. Of course, we can go back to our Karma preview and increase the absorption color, saturation of absorption color here, and you will see that we have this really nice kind of peachy color. Now let's view from our camera. Whoops. Not through light, but through the camera. And indeed, you will see that, let's tweak it ever so slightly, kind of like more horizontal position. Increase the camera. As you can see, focal length has been whacked a little bit because maybe it did not understand the focal length number previously, but you know, it doesn't really matter. So it's whacking a little bit, nothing to be scared about. It's always fine. So that's that. The last thing we can do is kind of tweak the intensity of our area light. I guess what I'm trying to say is tweak it to your liking. I think this looks really beautiful. I don't see very well the final part, this part here. So I think we can zoom in, decrease the focal length of our camera, let's say 45,000. And so there you go. The last thing we can do is get back to our Houdini GL, save everything, and of course, select our USD render up, press render to end play, wait for a couple of seconds so it kind of initializes and actually starts the render, and get the render. As you can see, it started rendering, everything is looking fine. As a final suggestion, I would say you can actually go into the image output, go to the filters, and as a denoiser, you can pick Intel Open Image Denoiser. So when the rendering actually is finalized, the final result of our rendering will be denoised by Intel. So let's do just that. All right, so what I want to do is get this camera, move it before the Karma render settings, because this should be the last thing, and change the resolution to Full HD, press render to end play. All right, so here we go. This is our render, and I'll skip a couple of seconds. I'll see you when it renders to 90%. All right, so about 5 seconds left. As you can see, here is a little bit of a noise. It will be denoised with Intel OIDN in a couple of seconds. Yep, here we go. Everything looking fine, pretty much zero noise. Let's press the home button so it kind of looks fine. And there you go. That was kind of nice and easy, right? So the last thing you want to do is maybe just to move your camera about. Again, if you're not sure why your volume isn't rendering, is because the Karma XPU requires the volumes to be VDBs. So even if you have just a volume that's not the actual VDB, so let's see, sphere, convert to ISO offset, right? It says only volumes. You can go to convert VDB and convert VDB from to volume to VDB. As you can see, here is volumes, here is VDB, and then it will render in Karma XPU without any problem. So there you go. So hopefully you enjoyed this video and learned a little bit about working with volumes and rendering, of course, rendering with Karma, the XPU Pyro preview shader, and how to create your own volumes and work with different types of clouds and how to create clouds. As I said before, we will definitely take a closer look at working with volume LOPs and everything else after we go through the attributes workshop. So if you want to learn more, don't forget to subscribe. Of course, if you have suggestions and ideas, don't hesitate to leave a comment. And hope to see you in the next video. Thanks for watching, and bye-bye.